All right, in section 3.4, we're going to talk about equations and kind of formalize the approach, some of which we've been using already, to equation manipulation. So let's start out by looking at a very simple equation. 2 plus 3 equals 5. And let's talk about how we were going to manipulate equations to help us solve for different things we want to solve for. So if we have 2 plus 3 plus 5, whenever we have an equation, we can add or subtract a value from both sides, and it won't invalidate our equation. So we're looking here at 2 plus 3 equals 5. We could add 2 to the left side, and if we add to the left side, we have to do the same thing on the right side, and we end up with 2 plus 3 plus 2 is 7 equals 7. So our equation is still valid. The other thing we can do to equations is we can multiply or divide both sides by a value. So again, if we have 2 plus 3 equals 5, we could come in and we could multiply this by 2, then have to do the same thing to the other side. And what I get is 2 plus 3 plus 2 times 2 plus 3 over here is 10 equals 10. So this is the methodology we want to use. Just to demonstrate, we could do the same thing with division. Suppose I multiply this by 1/2, or multiplying this by 1/2. I end up having to multiply this by 1/2. Multiplying this by 1/2 is the same as dividing this by 2. It's 5 over 2. And this, of course, also equals 5 over 2. So let's extend these ideas. We can use this approach to solve for variables. Suppose we have x as a variable plus 5 equals 13, and we want to know what x is. Okay, well, this is the same thing as x plus 5, so we want to get rid of 5 on this side and isolate x. Well, one way to do that is to subtract off 5. So if I subtract off 5 here, I have to subtract off 5 on the other side. 5 minus 5 is 0. Means that x plus 0 equals 13 minus 5 is 12. So x equals 12. Of course, if you took math in 2nd grade, you probably realize this is actually 13. 13 minus 5 is, it's none of those, actually. What am I thinking? 13 minus 5 is 8. Okay, let's try another one. Suppose we have 3x equals 15. Well, this is the same thing as 3x. If I want to isolate x on the left side, what I could do is get rid of that 3, and the one way to get rid of that 3 is to divide by 3. So I'm going to multiply by 1/3, which will result in division by 3. So then I have essentially 3/3 times x equals 15/3. And obviously 3/3 is 1 times x, which is x. So now I've isolated x over here equals 15/3. And we could further reduce this. 15 divided by 3 is 5. Okay, section 3.5, we do the same thing, but we're using a little more complexity. 3x minus 2 minus 2x equals 5 plus 2x minus 2x. So suppose I have these two. I have two polynomials, and there's an equation. One side equals the other side. And so I want to solve for x. Well, the way to do that is to isolate x. So maybe the first thing I ought to try is, instead of working with all these terms, I can look at this and I can simplify things on either side. Like terms, I can. So this is using some of the ideas we learned earlier. Like terms, I can combine. So 3x minus 2x is just 1x, or x, minus 2 equals 5 plus 2x minus 2x is 0. So, okay, sometimes things are just that easy. X minus 2 equals 5 here. We could add 2 on this side. It means we have to add 2 to balance the equation on the other side. These are going to eliminate. That leaves us with x equals 7. Okay, let's try one more example. So, okay, 4x plus 3 equals 3x plus 8. You rewrite it here, 4x plus 3 equals 3x plus 8. So I want to isolate x over here. So it's going to be a combination of subtraction. So maybe the first step is to subtract 3 here from both sides. That eliminates that. That 8 minus 3 is 5, plus 3x equals 4x. Okay, I need now to get this over here so I can help isolate. So I need to get all the x's on one side, minus 3x. So again, these cancel, we end up with 5 here. So minus 3x plus 4x is just x. X equals 5. Okay, one last example. 3x minus 8 equals 6x plus 10. Let's solve for x again. So I need to get my x's on one side and everything else on the other side. So we could put the x's on either side, and it would probably be easiest to get our x's on the right side here. But what I'm going to do is I'm going to solve this so that my x's are on the left side. So I have that to get rid of the 6x over here. And then I need to get rid of this 8. Since this is a negative 8, I'm going to have to add 8. So I add 8 there. I have to add 8 over here. So now that gets rid of 8 minus 8 is 0. So now I can reduce things that I have set up. Minus 3x. Minus 6x plus 3x is minus 3x. Combining terms over here, we get 10 plus 8 is 18. Okay, so next thing here, well, we got to get rid of this minus 3x. We can do it in one shot here. We could just divide it by minus 3. Minus 3 over minus 3 is 1. It means we got to do the same thing over here. So minus 3 over minus 3 leaves us with just x. And 18 divided by 3 is 6, but this is negative. That's positive divided by a negative equals a negative. So 18 divided by 3 is minus 6. So x equals minus 6. Now, if you're doing this on a test, you probably want to check your answer before, at least before turning your test in. So if we have 3 times x minus 8 equals 6 times x plus 10, if that is our original equation, and I'm saying negative 6 makes this, solves this equation, then I can stick in minus 6 for x here, minus 6 for x, so then I end up with minus 18 minus 8 should equal 6 times minus 6 is minus 36 plus 10. So minus 36 plus 10 is minus 26. And minus 18 minus 8 is minus 26. So yes, it works. All right, we'll do the last section on another video.